Well, hello folks, and welcome to episode 194 of Retro Power Uncut. And here we are in the fabrication shop, the very quiet fabrication shop, because everybody other than me and Jamie are having their lunch. And because there was so much going on in here, I decided it was probably a good time to try and do the job at lunchtime. It means you're not going to see anything actually happening on camera, unfortunately, but you also wouldn't be able to hear anything. You certainly wouldn't be able to hear me if what has been happening this morning was going on now. So this seemed an opportune moment to grab. We're going to just pretty much go through the workshop from this end to that, because there's all sorts of things going on all simultaneously. So literally right around us now, a bit of a construction job's taking place. We're making some bits of infrastructure. Martin, our handyman, is doing various bits of construction for background projects for our new venture, which we'll be seeing develop shortly, hopefully. Things are bubbling along in the background, but for the trim shop, we need a bit of infrastructure building, and for one of those bits of infrastructure just there, in front of me at the minute, is a gluing bench, which will have rear extraction on it, just to sort of keep fumes out of Richard's face when he's doing glue work, and also to keep glue overspray from going over everything. And these are some beams that are part of his big trim table, the major, like the 3 metre long trim table, which we've welded and altered because it's being the base of that's built from some pallet racking, and we want to paint them so it all looks nice. So these bits, Martin's just doing a bit of prep, getting those ready for paint. So that's why those things are there. Behind that is the Audi S4, which will be the running gear and structural donor for the Saab project, which is lurking that side. Mark completed the strip down on that at the very beginning of the week. Again, we're Thursday today, just sort of for a time frame reference. So you saw that last Thursday, I think, being stripped down. And this Thursday, you're seeing it having been stripped to the point where it needed to be stripped to. That was completed on Tuesday morning, I think. And since then, it's been resident here. And Luke has been doing some scanning work on that, capturing all of the other data that we need before we get into doing some redesign and some cutting work. But we also need to get the body shell clean before we start that cutting work. But yeah, the design work necessitates us being able to put the wheels through their travel. So we've pulled the suspension apart on it, taken the springs out, reassembled it, so that we can put the wheels on, but put the suspension right through its travel from full droop to full bump, from lock to lock. Same on the back, full suspension all the way through its travel. We've got steering wheel and pedals in place, and all of the, so we've got controls in place, and we've now got all the interior pulled out so we can see the seat mountings, the inner sills, all the structural areas that we need to get. And Luke's been getting all the scan work done on that, so that we've got a basis to work from, and he'll be getting all that data into the Peel software, the Peel to CAD software, getting all of that cleaned up, all of the scans stitched together, and creating a massive PC melting file of structural layout for that Audi S4, which we can then unpick and take to pieces and graft into the pieces that we need of the Saab. As I say, you'll see it develop. You saw it develop with the Allegros, and you saw the sort of principle at play there. There's a similar principle at play here. So watch and see as that develops. Moving on from that, got XJC. Lots going on that. Really good progress, actually. That's chiefly been split again, with Tom working on the rear of the body shell and Matt working on the sill. So he's been replacing the inner sill. We actually had, it was quite nice, we had the first, we have used our new very old Bronx press brake for a couple of other little jobs, but it's the first time we've actually used it for one of the main things we got it for, which was folding very long parts in a very straight line, which we couldn't really do before. The maximum fold length we had previously was 4 foot on Kerry Keytoner over there, as she's called, or our other Morgan Rushworth folder that we've got over there. They're both 4 foot folders, so that was our limitation before. Obviously, with the press brake, that's now 8 foot, so we can fold. In fact, it's 2.5 metre. So we can fold much longer lengths, and we can maintain a very straight fold. Neither of those machines, even at a 4-foot fold, would really keep that fold dead straight. It's particularly in, say, 18 gauge material, you'd get a slight bowing because there was some slight give to the middle of the machine. On the press brake, folding 18 gauge, absolutely dead straight over 2.5 meters. So Matt has made, involving a full length fold, a new inner sill section for the Jag. The inner sill on the, which is it, the near side or the off side? I lose track. On the near side, yeah, the near side, am I all right here? Yeah, I'm all right here, aren't I? On the, yeah, the near side inner sill was much more rotten than the offside, and it needed replacing up to the start of this radius at the top on that side. So so Matt's created a new section for that, folded it, got that grafted in. He's just TIG welded. I saw him just TIG welding that in this morning, getting all that grafted into place. You saw last week that he'd already pre-shortened the floor pan for that side, so he's got that just clamped in place at the moment and screwed in place. He's been doing the various bits of alignment on the brackets that needed removing and putting back to be able to fit that floor pan. So that's progressing really nicely. I think by end of play today, he's probably going to have the floor pretty much in place because he'd done all the prep work beforehand. So I think then he'll still have all the brackets to put back in, the seat mountings and everything to get realigned and put back in. He's got to rebuild the seat mounting box, which is on that table over there. That's going to need a bit of rework and rebuilding. But then, yeah, we're getting through the structural work pretty well at that point. That's all coming together nicely. The seal channels that we replaced on this side, they're going to need replacing on that side as well. Yeah, that's all fairly straightforward. We've got a good plan for that. Then moving on from that, on the rear end, Tom has basically finished fabricating all of the various sections for that. He finished the bumper mounts off at the beginning of the week so we could get the body shell back onto the rotisserie. He's put the various modified edges onto the rear valance so that the rear valance can fit in the new way. You'll remember from previous episodes we're making the valance so that it's removable, so it's a bolt-on section, so we can remove it fairly easily, and it's not a big rust trap. So that's done. The new edges are put on the valance. The rear panels are all spot welded in place and plug welded in place, and the valance has been trial fitted. We're just stripping the paint off the corner panels to determine whether we want to replace them or not. I think we're going to reuse them because I think they're already replacements. They certainly appear to be, having just dipped the paint off those, they appear to be largely, they appear to be replacements. So I think we're going to be able to reuse those. So we're just cleaning those up at the minute. And then we'll be able to put all that lot back together and just trial fit everything, put all the fasteners in place and make it all, so just trial fit, make sure everything fits together correctly, because I think there are a few little tweaks needed. But in the meantime, because Tom can't really do that while Matt is doing the sill, Tom's moved on to the wheel arches because we are very slightly modifying the rear arches and they need rot repair. So the wheel arch is being moved up by approximately 15 millimeters in the center. This black line is basically where the new arch lip is going to go. That's the slight modification. There was a lot of toing and froing between Cal and the customer for this car to determine the new arch shape. And he actually quite liked the arch shape as it was, but he wanted it slightly raised. So we're keeping the same lip profile but moving it up by about 15 millimeters. Tom's putting all the pieces in place to be able to make those wheel arches. We've had a little chat about the various ways it could be made. We know we're going to have to cut this back probably to somewhere around there to deal with the rot and remake the lip for the inner arch. And we know we need a former to make the outer arch. So Tom has made a cardboard template of the profile of the outer arch. I'll probably put this in the wrong way around now. Yeah, I don't know which way around this goes. Probably that way, actually. So he's made a cardboard template of the profile of that outer arch. Chuck that on the floor, put a tape measure along it and photograph it so that we've got a reference for the length, and I can scale that image as a canvas into Fusion. Yes, there are various lens created errors and things by doing that, but it's accurate enough for the purpose of the job it's got to do. So draw around that in CAD, set it up in a sketch, mirror it, and we've made a one-size-fits-all piece of plate that should have the right profile for that arch on it. It remains to be seen whether that's exactly accurate. We'll find out. But we've basically made this piece, which is then mirrored, so it can be used for both sides. That's then going to be rolled. That's cut in 6 millimeter thick mild steel plate. We'll roll that. I've literally just taken the forklift around and dug out our old big set of plate rolls, so I'll let Jamie get a bit of footage of those. I literally dumped outside the door because I think we'll probably struggle to roll this in our rolls in here, but the big old rolls will roll it no bother. So Tom's going to roll that, get it to the right profile, then he's going to check that it's somewhere near. We can titivate the edges and fiddle around it with it a little bit with a grinder just to get the profile exactly right for the wheel arch. Once that's done, we can use that to shape the new arch lip. And we'll have then something to knock that arch lip over to give us the initial shape. And from there, he can then generate the rest of the shape of the panel. But the key is initially having a curved piece of steel that actually gives us an edge to knock over. What we'll do once that's been rolled is we'll tack and stitch weld inside that a piece of box section right down the centre of that piece. We'll curve a piece of probably 1 inch, but maybe 40 mil, not sure yet, box section. We'll bend that in the press to form a curve. We might have to heat it as well a little bit, I don't know. Probably be able to just bend it in the press, I have done before. Bend a section to fit in it reasonably nicely inside that and stitch weld it in to try and stop that springing and splaying, and then that'll be a good jig to allow us to knock that edge over on to give us to define the line of the quarter panel around there. So yeah, good progress on that. Moving on nicely. We're getting well through the metalwork on this. And I've mentioned it before, there's been a bit of a delay for a couple of reasons, but we are hopefully shortly, next week I believe, going to get the parts we need to do the dry build on the running gear on this, so the engine and axle assemblies from Simply Performance. Should be getting those next week now, so there's a slight delay. I believe Ben from Simply Performance has had a new arrival in his family, so he was dealing with that. But I think they're back on with sorting the parts out, so we should see those next week. Moving on from that, I think we'll go on to the E-Type. I might scuttle around in this direction if I can get through. Bobby's been doing some prototype work on this. It was one of those sections where you set out to make a prototype with the view that if it works, then it'll actually be the final part, and if it doesn't, then it'll just be a prototype. And it ended up being a prototype. It was very, very, very close to working, but just not quite there. But Bobby's made a new B-pillar, basically, a new front section for the B-pillar. And it's actually going to be a new entire B-pillar so that it can accommodate the soft close Tesla door latch. And it's an interesting panel to make because we wanted to retain the spot welded step at the front that the quarter panel locates on. The quarters are being remade, the entire rear of the car is being remade, as you'll remember from previous episodes if you watch us every week, from a book that we generated, which was generated from a CAD drawing of a revised shape for the rear of the car. That book is with Andy Hall at Vintage Machines, and he is making that rear end for us at the moment. He's more experienced with that type of work than we are, and he's the man to go to for custom, very technical and quite awkward sheet metal work like that, prototype panel work effectively. Andy Hall's your man. He and his business partner Sam are currently working on that at Vintage Machines, and I think they're getting fairly well through that process now. And anyway, coming back to this, we wanted to retain the spot welded seam at the front of the quarter panel, and that necessitated remaking the outer part of the B-pillar, and we needed to remake the inner part, the centre part of the B-pillar to accommodate the latch as well. And we also wanted to add various reinforcement to the inside, hence the cardboard aided design there. So I think I may have mentioned last week we were going to make some formers to do that job on. Bobby has done that. He's drawn up the section, then cut that from some 6mm steel plate. He's made some swaging blocks, and he has then press formed the recess into the panel blank to receive the door latch mechanism. He's then knocked over this first edge as a long edge over the steel former, which involved some application of heat and a lot of chasing to pull that edge over there. And then he's used the jenny or bead roller. We call it all sorts of things. We would refer to it generally as a jenny. Use that to turn the second edge and then knock that edge back with a hammer and dolly after turning it on the jenny. But the interesting bit about that, and we'll go round, I'm going to go this way now, Jamie, just to create difficulty for you again. But we've got a good view here now. Jamie's got plenty of footage of this, but we've actually got a piece. This is the final part. That's the prototype part over there. This is the final version, which Bobby is literally just mid-operation on. So you can see in the centre, the piece where he's swaged the recess for the door latch. That's a pressed piece. So he's CNC cut the former for that, the outer and inner sections of the former for that, and then pressed that in, I believe, in the hydraulic press. I was just looking to see whether he's done it in the fly press, but I think he's done that in the hydraulic press next door. So he's pressed that in the hydraulic press, which I imagine was taking a fair chunk of the hydraulic press's output to do that. They're 20-ton presses, and I imagine it was fairly close to needing that to do that in 18 gauge, which is what this material is, 1.2 millimetre thick. So yeah, quite a lot of press pressure. And then it goes through this phase of looking pretty messy. He's knocking that edge over now, over this steel tool, which is, the steel tool is a layer, I'm just looking to check to make sure I'm speaking correctly here, but yeah, the tool is 2 layers of 6 millimetre thick mild steel plate, CNC plasma cut on our CNC machine through in the other room, which are then tack welded together. He's then got that bolted down to our Mac fixture table, which is a really useful item to have, and we've got that clamped down with a multitude of clamps, as you can see, because you can never really clamp this sort of thing down solidly enough. Put various clamp blocks on it to hold everything in place and stop it bulging, because whenever you start trying to knock an edge over like that, it usually tries to create a bulge right next to the edge, which is then very difficult to get rid of. So he's got that clamped to try and resist that bulge forming, and then he's knocking that edge over and then applying heat so we can shrink this edge. It would be it's possible, but very difficult on a material of 1.2 millimetres thick to cold shrink that edge without continuously having to remove the panel from the former and put it in a shrinker. And it's also difficult to put in a shrinker because of the curvature of that edge, particularly where the radius is quite tight. It really just needs to be hot shrunk. So you heat it, you knock it over, it forms wrinkles like that, then you heat them again and you knock the wrinkles out. You flatten the wrinkles out as you go. So he's getting that pretty well to shape. At that end, as you can see, that's pretty well to shape. This end's mid-operation, but by given another 45 minutes or so, that will all be knocked over and all be fairly flat. So it will all be like that section, a 90-degree-ish return from this face. Once that's all done, you'll then mark on the line all the way down that face where that next turn needs to be put on for the flange that's going to join to the quarter panel. You'll mark that on. You'll then run the jenny or bead roller down there with a tipping roll, as we would call it, basically a roll with a pointy part on it onto a flat roll. So we put a flat roller under there, a pointy roller onto there. That'll put a crease line down that. You put a light crease all the way down it, probably 2 passes with a pointy roll down there. I'm trying to use descriptions that everybody will understand, but basically a sharpish edged roll all the way down there, which will put a fold line in it, a crease to fold it in, and then you basically run the panel through the roll and tip it up. You lift it, and that'll gradually tip that edge on. That'll then put another row of creases and wobbles down that edge as that needs to stretch and shrink, and it will also bow the panel in the top to bottom direction, and that way it will bow it that way as well. You then have to take that bow out, and that's where things get a little bit challenging, because by that point you basically have a Z bend in that. You have a Z-shaped bend there, and that will resist bending in that direction. It will be bent in that direction. It will greatly resist being unbent in that direction. And that's where Bobby's done some hot shrinking again, but actually rather than hot shrinking where you heat the material, you bend it over, and then you crush these whatever you call those, these flutes. You crush these lumps out. You shrink them by crushing them onto themselves and flattening them, which thickens the material, and you use a little bit of heat to make the material more malleable in order to do that. We'll actually be using hot shrinking to actually pull the material, and that's a different process entirely. I'll just go slightly on a tangent because I see a lot. I'm going to do a little bit. We might actually do an autofocus on this because there's so much misunderstanding of heat and its effect on bits of metal. I read so much and see so many videos which are done by people who don't understand what they're dealing with when they're doing that. And it's a very important piece of fabrication in the whole fabrication world, not just in cars, but bridges, aircraft, you name it, whatever you make, where you weld some bits of metal together, heat control and the effects of heat are very, very important. So I'm just going to, rather than going off on too many tangents, I'm just going to talk about it with its effect on this particular piece here. Once there is a Z-shaped fold on the edge of that piece, to make it curve that way or that way, you need to make that edge get shorter or longer. When it's got a Z-shaped fold in it, you can't use a conventional shrinker, which would grab the material and push it together, or grab the material and pull it apart, because it will only affect the second edge. There's no way that can then transfer that shrink through to the section above the step. So in order to be able to shrink all of that material, a way, pretty much the only way I know of that it's possible to do that is to hot shrink it. And what you do to do that is you would get that panel and you would heat a sort of a pie slice shaped section of this double flange, this stepped flange that you put on the edge. You would heat it up, get it sort of to a red heat with a cutting torch. We would just use cutting torch, basic cutting torch like that. Heat a section of that, like a pie slice section of that, so wider at the edge where you're going to need it to shrink the most, up to narrower where you need it to shrink less, i.e. as you get further into the panel you need to shrink it less. So you would heat that pie slice to red heat and then you would cool it down. You can either just let it cool naturally, or generally I find a better result is to cool it with a compressed air blower. But you would cool that slice down. Now, as it heats, that material expands outwards, and it's going to expand lengthways mainly, and it will also try and expand upwards. But if the material is really well restrained from going in any other direction, which it will be if it has a Z fold in it, the only real way it can expand is lengthways with the material. As it expands lengthways, it's restrained, it can't go anywhere, so what it actually tries to do is push into itself, and it actually causes the material to thicken very slightly because it pushes into itself, has no other direction to go. If you restrain that material, it can't go anywhere else other than into itself, so it pushes into itself, upsets itself slightly is the correct term, thickens itself slightly. Then when you cool it down, it doesn't actually have time to thin itself back down again and pull itself back. It creates tension as it cools and it can't pull that material back. It's kind of in there when it's upset into itself and stays there. It can't come back. So what it does is pull the material back with it. So when that little pie slice that you've heated up cools back down, rather than dragging the material that it's pushed that way and that way back, it just pulls the whole surrounding metal with it. And it's only on a very small scale, but it actually pulls it all with it. So if you do that in a repeated sequence all the way down the side of that piece, each time you do that, it might pull back by, I don't know, 0.1 of a millimetre, 0.2 of a millimetre. But if you do that in multiple locations, by the time you've done it all the way along the side, you might pull, say, 1.5 millimetres of material back, and that would be enough along that edge to take a huge amount of curvature out of that panel. And that is the principle of hot shrinking as applied to that. The hot shrinking is used, as I say, in many, many structures. If you fabricate a frame out of some box section steel or angled steel, everywhere you put a weld, it'll shorten. So if you weld a number of welds down one side of a length of box section steel, it will curve the box section, because every time you do a weld, it will shrink the face of the box section that you're welding to. It will pull. And there isn't really much you can do about that, but what you can do is you can heat the opposing face of the box section. Every time you heat a section of that to red heat, it will expand, where it's the material, the coefficient of the expansion of the steel will make it expand. It will push into the box section around it. It'll try and bulge outwards a little bit as well, but again, because it's restrained, because it's a shaped piece of material, it can't really just go in every other direction. So what it tends to do is push into itself, upset itself, thicken slightly, and then when it cools down, it pulls back, and it can't pull that material back, so it actually just pulls the box section with it and pulls it back straight again. And that's what happens. That's how you straighten material where it's been pulled by welding. You can generally pull it back by using heat to pull the opposing face by the same as the welds have shrunk. Now it's quite difficult in that a weld shrinks by more because you've applied filler metal, which is applied at a high temperature and then shrinks. That's applied a lot of shrink because there's more material pulling the restraining material with it. So it does take a little bit more work with the gas torch, and you have to do more shrinks with the gas torch to compensate for the lines of weld you put the other side. I'm hoping I'm not making complete gobbledygook here. At some point I'll plan out an autofocus episode where we'll talk specifically about what heat does to metal, what welds do to metal, and how you can counteract that, because it's probably, I've found, the least understood area of fabrication that I've come across. Anyway, I think that's pretty much covered with a big elaboration off to one side. What Bobby has been doing on the E-Type is basically manufacturing new B-pillars, and this should be the first of the final pair of B-pillars that's being built for that car, with the soft close latches and the auto close mechanism built into them. Going back to where we started, that was his initial template for the outer edge of that B-post, and that's where all of this started. Also, that is the press tool sways blank, but again, Jamie will have had plenty of coverage of all of that in his footage, so you'll have been able to see all the background to that going on there. I think that's about where we better leave that. We'll now swing round to Interceptor, and I'll talk about this quite briefly. Stu's on holiday. Even Stu has holidays. Stu's actually on holiday at the moment. He was working on two areas earlier in the week. Continuation of the air conditioning line mock-up, fitment, specifying the fittings, doing the little drawing of where they've all got to go, and working out the exact layout of the system. And to that end, he's fabricated a little section into the inner wing to allow the bulkhead fittings to come through and nothing to foul the wheel and nothing to get in the way. He's made up, in fact I think he's actually swaged now, he's made up the two flexi lines that go from the aircon compressor to the bulkhead fittings, and then the lines that go from the bulkhead fittings out of the back, they're mocked up but not yet swaged. They go from there across under the front of the car, where we were talking about putting the lines under the slam panel, to the condenser, and the other one then goes across and then goes to a union point where it's going to mate to two hard lines which run down under that inner wing to the HVAC unit. But I'm not sure whether or not he has done the hard lines yet. Did you say you had some footage of Stu making the hard lines? Okay, yes. I haven't actually seen those, but Stu's then made the two aluminium hard lines which go down under the inner wing that side. I think I mentioned it last week. I'm mentioning the same again, but hopefully very, very soon we'll have the parts from Jonathan at PBE CNC for our sway end forming machine, and we can actually end form those hard lines. I'm really looking forward to getting into that. It's another little project that I'm unreasonably excited about. So I like the little engineering projects, as you'll have gathered by now, and that's one we're quite keen to get into, because we don't know of anybody else at all in the industry that's doing that. I don't quite know how people are doing AC hardlines, but nobody that I know of, and I've spoken to companies that are dealing with low volume manufacturers, and I can't find anybody that's doing it. So I'd be interested to know how other people are doing it, but we're doing it ourselves. So that's pretty much where it's a very brief stint on. Oh, sorry, no, there's other bit. There's Stu's other area he's working on. The doors, as were on this car, had the holes in the forward end of the door frames welded up where the wiring would have gone in. So I don't quite know what the plan was with getting the wiring into the doors, but there are no holes. So Stu's been planning the wiring routing into the doors, and that kind of led into also planning how the seals are going to work and whether the original Interceptor sealing methods were acceptable, which actually they are. We were unsure how the seals worked on these versus the CV8, because on the CV8 they're fairly terrible. On the Interceptor they put a bit more thought into it, and they've actually put a bit more thought into the way the door seals work on these, and actually they're pretty good. So we're going to be using largely the standard Interceptor door sealing system. However, we're changing the way the wiring goes into the door and doing a few little alterations in the door shut. So Stu's been planning the door wiring routing, doing the cutouts for the, I've the gaiters that shield the wiring where the wiring goes from the A-pillar into the front of the door frame. So he's been doing the cutouts for that, planning that routing, and we've actually had to bore some holes through some fairly decent structural parts of the A-post to be able to actually get the wiring through. But that's pretty much in place now, I think, or certainly the plans are all in place, if not the execution. So yeah, that's what Stu's been up to, but as I say, he's actually on holiday at the moment, so that's where we're at on that. Moving on from that, body shop wise, there's progress on all sorts of things, and here's Mark right now. Mark's doing a couple of little bits of rectification work at the minute. He's painted, Mark was blasting on day before yesterday, so on Tuesday Mark was blasting. Yeah, he finished stripping the Audi on Monday. Tuesday he was blasting. He blasted the 2 fuel tanks for the Allegros, which are actually Honda Integra DC2 fuel tanks. They were both in fairly good condition actually, so Mark's blasted both of them, got them nice and clean. They still had, they still had the like a coating of anti-stone chip. I believe it's PVC, but it's certainly a rubbery plastic coating. I don't exactly know what it is, but they had a coating of that sprayed around the edge of the tanks, which was actually in imperfect condition. So we've left it on. We've then epoxy primed those tanks. I have to keep pausing because there's so much to remember. We've then anti-corrosion epoxy primed both of those tanks and then coated them in U-Pol Raptor, tinted with black acrylic 2K, and they've come out really nice. He's done a texture on those which is sympathetic to the original anti-stone chip covering that was on them, so they look really nice now. They kind of look OEM. They look very much like they sort of would have done from Honda, with the stone chip protection on them. So they're done. They're ready for sort of all the various assembly work to pick up on now. But they were a refurbished part. A lot of the parts are going to be new on those cars, but they were one of the parts where we can't get it new, and the originals are in fairly good condition, so we're going to reuse them. Mark also, while he was blasted these, which are the door inners for the XJC. They were actually, as I mentioned last week, in pretty good condition. A little bit of repair needed at the bottom, but nothing too drastic. And we're going to reskin them. So Matt got the skins removed on those at the end of last week. Mark's now blasted them, and again used the Ceramix zinc-rich 2-pack epoxy primer on them, which we've been asked about before. Again, if you want to know what it is, just ask in the comments and I'll post again what it is. I can never remember the number. Ceramix use a numbering system. It's like some numbers and some dots and some numbers and some dots and some numbers. I can't remember all the flipping numbers, but I can post it in the comments if you want to know what it is. It's a Ceramix, very high zinc content epoxy primer that we use. I believe it's mainly aimed at the marine market. However, it's just a very handy all-purpose primer for us. In that it's high build, extremely high corrosion resistance, and incredibly tough, and it's waterproof, so it's a really good basis for lots of work that we do. So that's what's on those. And then moving on from there, we can look into, it's almost like looking back in time. It's an Austin Allegro production line in here. So as you can see, I was talking to Gaz a bit earlier in the week about the order of events, and Gaz wanted to get both shells to kind of a similar stage so that we're undertaking the various processes reasonably in tandem. I think his plan is basically to get the final paint on both shells pretty much one straight after the other, so that when we do a big cleanup in the booth prior to doing that final paint, which is one of the downsides on another side track of only having one booth. It would be nice to have a dirty booth where we could do our Raptor work and our primer work separately. We just don't have the floor area to have a second booth, otherwise we would. It would be nice to do that dirty work. The priming leads to a lot of dust in the extract filters and a lot of dust on the walls, just primer overspray dust. And you don't really want all that in there when you're doing your final paint. So what we tend to do is do all the dirty work and then do the final paint separately, after a cleanup. So Gaz really wants to get both the shells to the stage where we can do a big cleanup and then do the final base coat and clear coat on those shells in a clean booth. So that's his plan. So this one, Steve's working away behind there, so hidden behind the car at the moment. But Steve's block sanding the poly. This is is this acrylic 2K on this primer? Yeah. So that's primer. So they've blocked the polyester, and we haven't generally been using acrylic 2K, but we're using one coat of acrylic 2K on the high build primer on these. So the polyester high build has been blocked. Steve's now blocking the acrylic 2K high build at the moment, and then this will end up. Will this then have another epoxy over this, or is that it? Yeah, that'll then be its final blocking, and then that'll be ready for paint on the outside. But they've still got to do the Raptor undercoating on this one. So the next stages on this will be the so many things to remember. The next stage on this will be the Ceramix Direct black coat on the interior, then engine bay colour. Then Raptor underside, then engine bay colour on the second car, which Gaz is working on. He's doing the final blocking on the high build primer ready, which then will put that car at the ready stage for final paint. The reason for doing the operations in the stages we do them in is so that we don't end up doing the wet block sanding of the primers while there are any uncoated surfaces on the car. That's why it's a slightly bizarre sequence of events, but it's just to make sure that we're not doing any wet sanding operations on a car where all the surfaces aren't sealed. So that's what's going on there. So as you can see, as we mentioned last week, the far car is in its final colour of undercoat, and this one won't be too far behind that, getting to that stage as well. And obviously, there's a whole lot of panels also going through all that process simultaneous with that. So yeah, there's a lot's going on at the minute, and there's also a lot of parts prep going on. If you look on the table in the middle, there's a huge pile of parts prep going on for the Allegros as well, where we have the front grills being prepped, we have the foot plates that cover up the ECUs and the PDUs, the power distribution units that go in the passenger side footwell and up into the bulkhead. That cover plate leaning up there, that's the cover plate that goes over all the electrics and electronics in the footwell. We have the breather tanks for the engines on there. The two aluminium tanks are the breather tanks for the engines. Actually, no, they're the coolant overflow tanks. I'm getting myself muddled again. They're the coolant overflow tanks for the engines on those. And I can't see too many more parts, so I won't elaborate any further. But yeah, lots and lots and lots going on, all fairly simultaneously in the body prep area. I think that's covered the bulk of it. I think at that point, it's time to hand over to Cal in the assembly shop and see how things are progressing in there. So, see you next week.
Thank you very much, Nat. You're met by a remarkably spacious workshop. So first thing is the Land Cruiser. So the radiator had a leak on the core, so that actually went back to it went back via Concept Racing, who did the fabrication, to the core manufacturer. And the core manufacturer thankfully managed to repair the core without having to totally rebuild the radiator. So that came back, everything went together, and that got delivered back to the owner. So he's doing a bit of a tour out in it this weekend, fingers crossed. It's always nervous when you know like cars that have had minimal testing are going on fairly long trips, but it's the only way to iron out and find the faults. So hopefully there won't be any faults and he'll have a great trip. So that's that. Churchill, so a few angles of attack on that at the minute. Anthony's been working on the fuel system. So there was a tank drawn up and fabricated at the metalwork stage on this car. So we already had the provision in terms of the plinth that the tank sits on and the points at which the brackets were mounting at the bottom. Anthony's now made the fuel tank straps. They're just stainless steel, sort of rolled over and spot welded on the ends with the holes through. Let's put the anchor points in the bulkhead for the top part of those straps. There's foam padding around the tank, which is generally the way in a lot of these cars that we mount the tanks, just strapped onto closed cell foam. And then we've been working on the vent plumbing and the filler neck. So again, the neck was made up at the metalwork stage, so that was pretty much a case of just cleaning out the paint build-up, getting that in, and then working on the vent plumbing. So we've got the big diameter vent plumbing, which is basically to vent the air out of the tank when you fill it, which goes to a union right at the top of the neck, sort of above the end of the gun when you're filling it. So it vents the air out above the nozzle, avoids it kicking out when you're trying to fill it. And then there's the secondary vent, which is basically when the cap is closed, because the cap is not a vented cap, it allows air into the tank as you use the fuel, or air out as the fuel expands in the heat. And they're both duplicated both sides, so if the car's on an angle either way, there's always one at the highest point. So he's been on with all that plumbing, then moving on to the actual fuel plumbing itself. So he's got the pump and filter mounted in there, he's run the fuel lines into the car. They're in Racing Lines Superlight, which is what we use on a lot of the projects. Racing Lines just down the road from here, hence the usage. We've moved on to looking at some of the brake plumbing, so the servo and currently a used master cylinder in place of what will be the new one are in there, and we're making a start on running the brake lines. So again, we did the provision for all the routing when we were at the metalwork stage, but we're now actually making the lines. So we're going to run ATEC hard line on the visible one that goes from the T-piece for the front line across to the far side, and the short run on this side to the near side front caliper to bulkhead fittings in the inner wing. So that gets the pretty looking bit out of the way. And then the front to back will be Teflon lined, stainless braided, threaded fitting that runs the whole length to the back, T-piece on the cross member at the back, flexies all the way from the T-piece on the back, and then on the front it'll be flexies from the bulkhead fittings through the inner wing to the calipers. So that's taking shape, and then the radiator, there was a mock-up radiator made by Stu when he was doing all the metalwork at the front. The only thing we didn't have on that was a filler cap, so we just wanted to absolutely finalise the position of the filler cap. Adam's just tacked in a little extension on the back. What we wanted to do was get the filler cap sort of central to the rear face so that the bleed, which goes through the inner wing to a bleed tank under the inner wing, kind of goes exactly parallel with the back face of the radiator, so we can do a little welded boss on the back and hold it, and it's just dead straight line as it runs across. So Ad's just tacked in an extension piece on the back and a representation of the neck to give them the height they've got to play with for that. And that's going to go to Concept Racing now so they can fabricate the final one. So yeah, just starting to chip away at progress on that, which is great. Project 1, little bit of progress, not a great deal. I've been out testing this week, now everything's together. We're just kind of going through those final nitpick jobs. So we had the boot lock machined. Jonathan at PBE CNC machined the barrel for that, so that was to complete the lock set, which is now newly available lock barrels throughout and custom housings throughout, so it's our own machined housing. And then we've done the actual the rotary pin and the segment that actuates the latch is all our own parts as well, so it runs in a proper bush, and it's kind of a little bit more precisely engineered. And the feel, actually the owner commented when he had it back the first time, suddenly when you open the handles, you press the buttons, all that effort seems worthwhile because it feels so much nicer than a standard Escort. There's no sort of slop and flop in all the parts. So yeah, all the boot builds back in that, panel work behind the fuel tank's done. We've worked through all of the sort of post-shakedown list. So things like, I had temporary mirror glass in it before, we've got the final glass in the mirrors now. There was a little bit of a rub on the near to the clutch foot side of the driver's carpet on the edging, because actually your foot kind of rested on the edging, so just a little extension. Remade the driver's carpet with a little extension up the tunnel to avoid that happening. Little things like that. I've also been chipping away at progress on Project Kuma, so throttle bodies, trumpets going onto that. I'm trying to think what else Gibbo's been on with on that. We've been doing some of the finalisation of machining stuff, so the instrument binnacle, which is different on the two cars, has been finalised and the drawings sent for machining on that. That's an interesting one actually to mention for those who haven't followed us since we were doing these two cars. At Metalwork we had the owners who are brothers, so they're kind of a matching pair, but they're different in their driving positions. So we had them over to basically sit them in the car, get them in a comfortable position, hold a steering wheel in free space, which we then measured and positioned the positioning of, got the pedals in the right place, etc., etc. And the driving positions were so different that the instrument cluster on Project Kuma is massively lower down the dash, and where the steering column comes through the dash on Project 1, it's actually under the dash on Project Kuma. I'd say it's probably 2 to 3 inches lower. So the driving position was lower, further back, steering wheel further back. Consequently, some of the things are different, and one of those things is the instrument binnacle. So we finalised the drawing for that. So that's good. Allegros, we've obviously been gearing up for assembly work on those, and one of the things that we've not really covered at all yet is the engines. So there is one sitting here, and I'll quickly explain this, because at first glance what we've done here kind of seems a bit odd in that we've basically sandblasted the assembled engine. Now this is going to be completely stripped and rebuilt, and actually there is method in our madness in that to mask off all of the mating faces that have kind of critical components that might seal onto them. The easiest way to do that is actually for the engine to be complete, rather than stripping everything down and having individual parts and then trying to mask, say, the head face on the head, etc. The easiest way to do it is just to do it with it complete. Now, obviously, any external mating faces for ancillaries, or things like the exhaust manifold, where there are bolt-on parts which we've already taken off, those have been, we've done plasma cut steel blanks to go onto those. But the rest of it, we blast in situ like this. We have blocked all of the orifices and ports and everything, so they shouldn't get grit in there, but it doesn't really matter because at this point we're going to strip everything apart anyway, and then everything will be meticulously cleaned out. All the core plugs will come out, all the gallery plugs will come out. We'll clean down all of those oil and waterways. So actually, if there is any grit ingress, it doesn't really matter anyway, and it's just a great way of masking off all of the faces that are critical without much effort. So yeah, this is basically put into the blasting booth, complete, blasted, and now we're ready to start the strip down on this, get it down to just bare block, bare head, and see what we're working with. Now I expect, being a Honda, I'm anticipating it's going to be in very good shape, because usually Japanese engines generally of this era, things like the Toyota 2JZ that we did for Utah, the 1UZ in the Land Cruiser, you strip them down and they're like virtually like new inside. It's just the level of engineering in sort of Japanese 90s stuff is extremely impressive. So that was where we're at with that. Actually, out the corner of my eye as well, I can just see we're starting a bit of strip down stuff on gear linkage and steering rack for the Integra Allegros as well. So we've got stacks of parts coming in at the minute. A lot of genuine Honda parts, because they still do a lot of stuff. So all of the moving parts from within the gear linkage, I've got all new bushes and fasteners as well, direct from Honda. So all of the moving wearing parts will be replaced, but the core parts, these link rods, will be stripped and painted. Steering rack we'll strip down, inspect. I don't imagine there's going to be any wear on that, so what we'll do is we'll mask various areas of it, clean it up, repaint it, put new track rods on it, new gaiters, and I would imagine the hydraulic part of it will be fine, but we will inspect it and check that. So yeah, basically gearing up for Allegro assembly. And then I think the other main area of attack this week has been upholstery. Very excitingly, now Richard's got his sewing machines in place, we've been making a start on the Allegro seats. And although Richard is extremely good at doing his little pieces to camera, on this occasion we're going to let the video do the talking. I'll leave you with some footage of what Richard's been up to, and we'll see you again next week.
Nobody's ever gonna take your place. Yeah, I think we should meet in the middle. I follow you 'cause you're the light.